I've been having a problem with my Campbell Hausfeld cheapo flux core wire feed welder, which has actually been a good welder. I've used it for, gosh, about 10 years now and beaten the hell out of it. But the problem I'm having is the wire speed control. Basically has no variability. It runs wide open, and then there's a few spots where you can adjust the dial that will allow it to feed at sort of a weldable speed. But normally you pick a wire speed that's suitable for the material you're welding and the amperage and etc. And this one, just something happened internally, and now it just runs wide open, just feeds wire like a foot a minute. I mean, not a foot a minute, but like a foot a second, which is just completely unusable. So what I suspect is that there's a cheapo Wongdeng Chinese potentiometer, like this one, that basically has got, it's either overheated internally because I exceeded the duty cycle, or it just got some schmutz in it, or it's corroded and it's got shorts. So the wire feed motor, there's a transformer, a small transformer here that's used to power the electronics, and including the motor. And then there's probably a simple like MOSFET driver for the motor speed control that reads this potentiometer and then sets an appropriate pulse width, etc., to get the wire feed speed correct. So I'm hoping, because I doubt you can get this board anymore, this thing's so old and it's throwaway electronics, but I'm hoping this pot is just bad and I can replace this pot and then essentially restore this welder to functioning state, because it does work good. It still welds. It's just the wire control part that's messed up. So I'm going to go ahead and desolder this, just heat them up, pull the terminals off, and then check this pot out of circuit. And if you look at the writing on it, it's supposed to be, looks like 50k ohm. So a pot is basically a voltage divider. You got a center point, which is like your wiper, and then you have a contact on either side of a wire wound resistor, usually. And essentially, you should see a smooth gradient. Like if you start here and go to this pin, you should see a smooth gradient with your resistance and effectively your voltage increasing and decreasing smoothly across that range of travel. And my suspicion is that it's got a short or an open. I don't know yet because I can't test it in circuit. But in essence, we'll find out. I'm going to desolder it, and then I'm going to check it with a multimeter. Just a cheapo digital multimeter. You can get these for like $3 at your Harbor Freight or Horror Freight. And we'll see if this pot's any good. And if the pot's good, well, then we have other problems in that circuit. I might take it apart further at that point and see if there's any burnt components or something that's obviously damaged. But if the pot's bad, well, that's a simple matter of go to a local Radio Shack or order off a DigiKey or something. Get one that's got the right package, so the shaft type, length, size, etc., and then obviously the right resistance value, and we should be able to fix it. So I'm going to desolder this, and we'll find out here in a second if it's any good. Alright, so I believe my suspicions are confirmed. You see I'm going from the center wiper to one side of the wire wound resistor, and in essence, right now, it's just showing an open over limit or out of range kind of thing. But if I wiggle it a little bit and move it around, I can get a reading here. Let's see. Now it's doing nothing. I would say it's a bad pot. So I'm going to get on DigiKey or Amazon and try to find me a replacement potentiometer. It's the right package for the overall physical dimensions, and then see if we can find one that's the right value and the right size and swap it out and restore this welder to service. But in essence, the reason it's feeding like crazy is the electronics are expecting a certain voltage. So say they feed in 5 volts or something like that to the center pin, and then they read the output. It's got both wires connected, so from either side of this, and then basically you get a relative range of motion, so it can figure out where this pot is set, and then apply an appropriate speed control via MOSFET or whatever to drive that motor. So at this point, because it's an open, it's not seeing anything there. So if you think of it in terms of voltage sensing, if you're varying from 0 to 5 volts, if 5 volts was low speed and turn the wiper 0 volts is full speed, and then it would make sense that when this thing failed and you have an open circuit, so there's 0 volts seen on that sense line, that it would run wide open, which is what it's doing. And, you know, I fiddled with it a little bit. You wiggle the contacts, and you could sometimes get it to read, you know, some range between, you know, 150, 200 ohms up into the mega ohm range. So in essence, there's a break internally, or the wiper's damaged. It might have a carbon brush or something in it that's just shattered or overheated or fractured or suffered some kind of environmental damage. But we'll replace this, which goes here behind this panel, and see if we can get this welder to work right again. Stay tuned. Alright, due to the magic of editing, it's 2 days later, and for about, I don't know, $2.50 a piece, I got a set, couldn't buy one, so I got a set of 50k ohm potentiometers that appear to be the right size, dimension, simple 3 contact. So, not bad. Amazon 2-day shipping. Anyway, I'm going to set up the soldering pencil heating up. Refer to the previous video to figure out where the wires went. There's only 3, so it shouldn't be too hard. Basically solder these back on and then do a quick test of the wire feed only, just to make sure it's fixed, and then I'll reassemble it. Back in a sec. It's going to be impossible to do this with one hand on a cell phone. The first thing I'm going to do is tin these leads. Flow a little bit of solder to them. A little flux on them from the solder. Just using normal rosin core. The idea is to pre-treat this so that the solder sticks better when I go to actually attach the wires. There we go, they're tinned. Basically what we're going to do, get my ice loose here, stick them back the way they came out. There's 3 wires. The order was red, yellow, blue. Find out. I don't think it'll be too critical. I think the worst case is the range might be reversed if we get it wrong. And the low speed will be high, the high speed will be low, but I don't really care. So I'm going to pause it, hook these wires up, and then we'll try to solder them. Alright, I definitely need to get a tripod. Anyway, they're soldered now. You can tell it's a good solder joint because you can see it's shiny like chrome. There's no contamination. It's not a cold solder joint. Cold solder joints usually have a dull, oxidized kind of look to them. Good solder joints that are hot, that flowed well, where the metal actually liquefies fully, will develop a glass-like surface due to surface tension and atmospheric pressure. So, quick tip. Anyway, these come with little insulators on them. So I'm just going to push back those just like they were from the factory. And then hook this potentiometer back in place. These will keep them shorting out. And we'll give it a test and see if it feeds wire at a predictable, usable speed or if it's still junk. Back in a sec. Alright, time for the moment of truth. Welder's off. I just got the ground clamp clamped to something not ground. And like I said, I'm not going to try to weld. I'm just going to see if it feeds wired correctly. So I'll turn on or on. You can see this is a really cheap unit, high-low. It does have infinitely variable wire speed. So we'll set it to, say, 3. Hey, look at that. So 10 should be super fast. Yep. And 1 should be slow. Adjust my feed rollers, but success. So this originally was probably a $250 welder, and that was probably way too much, but at the time there wasn't things like Harbor Freight in my area. So, and there is one good thing about this welder, is not an AC welder like the $100 ones at Harbor Freight. It is actually a DC. It's got an inverter inside of it, which you really need for flux core to work properly. But it's been good. You can see, I mean, I've beat the hell out of it. I use it a lot for lots of little projects around the house, and it does good. But about $2.50 and maybe 30 minutes worth of time total to repair it, and it's back in service. So if you have something like this, don't be afraid to take it apart and have a poke around. If you don't know what you're doing, obviously be extremely careful. There's obviously lethal voltages inside this thing. And if it's got capacitors that store a charge, it could give you a lethal shock even when it's not plugged in. So before I used it, before I took anything apart, I grounded this lead to the ground and hit the trigger.
and made sure there was no residual charge. And I left that wire clamped to ground to basically ground that circuit, so I could make sure it wasn't building up a charge, sitting in the air or anything. And no issues, no shocks, no problem. So I just got to put all the little screws and panels back in it, and she'll be back for, hey, who knows, maybe another 10 years. Thanks for watching. Comment, rate, subscribe.